In this video, we're going to talk about what is torque. So we can think of torque as a twisting force. But I'm going to put the word force in quotes because it's not really a force, because a force is measured in newtons and a torque is measured in Newton meter. So to understand what torque does first is we want to think of an analogy with linear motion. So in linear motion, we know that if we have a net force, then we will have an acceleration. So Newton's second law. When we have a net torque, and the Greek letter for the symbol for torque is the Greek letter tau. When we have a net torque, we will have what's called an angular acceleration. So the rotational speed is going to change. But what affects the torque? And first, that there are three things. The first is going to be the force. So how much force you're exerting on it. So if I exert a little bit of force, a medium amount of force, and a large amount of force. So the wrench on the right would have the most amount of torque because there's the most force acting on it. The second thing that affects the torque is the location of the force. So I could have a force close to the axis of rotation, a little bit further, and even farther away here. Okay, so all of these have the same force. So the difference here is the location. So the one that's furthest away will have the greatest amount of torque. The one that's close will have the smallest amount of torque. So the torque affects on how close or far you are from the axis of rotation, which is right there. And so the farther away it is, the greater the torque. The third factor that affects torque is the direction of the force. So if you have the direction straight down, or an angle this way, or an angle this way, let's assume they all have the same amount of force, and they're all the same location. The only difference here is the direction. When it comes to torque, the perpendicular direction gives you the most amount of torque. So this would have the most amount of torque. This would have medium amount of torque. And this would actually this torque would be 0. There'd be no torque. This would not cause it to rotate. So to get the most amount of torque, you want to have the biggest force. You want the location to be as far from the axis of rotation as possible, and you want the direction to be 90 degrees. So now let's talk about how we can mathematically calculate the torque. So there's a couple ways we can calculate torque. One way is to use what's called the lever arm. This is not the only way, but this is one way. So we can use the lever arm times the force that's applied. And so let's say that we were to push on this with this angle right here, a force in this direction. And so to use this method, we would draw what's called the line of action. So the line of action is a dotted line that goes through the force. Okay. And then the perpendicular line, perpendicular to the line of action, that goes through the rotation, through the axis of rotation. Notice this is 90 degrees. If we take this number, let's say this is 0.3 meters, okay? And let's say that this is 20, a force of 20 newtons, right? So if we take the lever arm, which is 0.3, times the force, which is 20, we get 6 Newton meters. So notice that this wrench is actually longer than 0.3 meters because this is a right triangle. Here's the 90 degrees. So this is the hypotenuse. So we know that this is longer than the wrench is longer than the lever arm. So we can see that when you are exerting a force at an angle other than 90 degrees, you're going to get you will not get the maximum torque. So to get the maximum torque with this force at this location, we'd want to push it 90 degrees to the wrench. That would give you a larger torque. Now, this is not the only way to calculate torque. Let's take a look at the other way to calculate. The other way to calculate torque is to use this equation. Torque is equal to r, which is the distance from where the force is acting to the axis of rotation, times the force times sine theta. Now, what the sine theta does is it gives you the perpendicular component of the force. And that is really what the component that matters when we're talking about torque. It is the perpendicular component. And so what this part does is it just gives you that perpendicular component of the force. So here we have a wrench, and it is applied at 60 degrees to the wrench. So we'll do 60 degrees right here, and here is our force, and our force is 40 newtons. And we want to find out what is the torque. And this wrench, we're told, has a distance of 0.25 meters. Okay, so to calculate this, we're going to take the r, which is 0.25 times the force, which is 40, times sine 60 degrees, and we get 8.66, and units are Newton meters.